Alright, this is the statistical regression unit review. Starting with number 1. The table below, X represents the number of years a company has been in business, and Y represents the number of employees the company has. Construct a scatter plot and draw a line of best fit using a straight edge for the data. So, constructing a scatter plot, pretty straightforward. We're just going to plot the points. So 1, 15, 2, 21, 3, 27, 4, 28, 5, 39, 6, 40, 7, 44, 8, 52. So that's obviously not a straight line, but what we can do is we can draw a line as straight as possible that appears to represent most of those points. And that was not very good, so let me try to redo that. See if I can do any better. It's good enough. So we've got a line of best fit that's going through most of those points. And based on the relationship, predict what the total number of employees will be when the company has been open for 9 years. So we go to 9, we go up to our graph, and it looks like we're going to have about 60 employees. Use your calculator to run a linear regression to find the equation for the line of best fit, round to the tenths. So to do regression, we're going to go to New Document, List and Spreadsheet. In A, we'll put, let's see, what was A? X was years. And our Y value was employees. And then I'm just going to type in my information from the table above. So we have 1, 2, well, it would help if I didn't do that. Make sure you're in cell 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go over to employees, and we've got 15, 21, 27, 28, 39, 40, 44, and 52. Alright, once we're done with that, to do the linear regression, we do Menu, Statistics, Stat Calculations, and we're going to do number 3, Linear Regression, MX plus B. It's going to ask us what our X list was, so we select years. It's going to ask us what our Y list was, we select employees. Everything else we can leave as is. Hit OK. Uh-oh. That means I missed one. 15, 21, 27, 28, 39, 40, 44. Oh, it's because there shouldn't have been 9 years, only 8 years. Alright, so we've got our 8 years. Once again, I'm going to do Menu, Statistics, Stat Calculation, Linear Regression, years for the X list, employees for the Y list, and everything else can stay the same. And we get our regression. So if we go up to the top of that, we have mx plus b. Tells us m is 5.04762, b is 10.53. So find the equation of the line of best fit. So our line is y equals 5.05, I rounded that, Actually wanted me to round to the tenths, so it's going to be just 5x plus b was 10.5. That's my equation. Explain what the slope and y-intercept mean in the real world context. Well, slope is the thing that's attached to x, and x is the years. And the 10.5 is the constant, and that goes with the y-intercept, which is where it crosses the y-axis, and our y-axis is employees. So the 5 represents an increase of 5 employees per year, and the 10.5 would be how many employees the company started with. Obviously, we can't have a half of employee, but it's a regression line, so we're okay with that. All right, number 2. Jamie purchased a student bus pass for $20. The table shows the amount of money left on the ticket after Jamie rides the bus X times. Construct a scatter plot and draw a line of best fit. So we're going to do the same thing. 3 rides is 1625, so we're way up here. 5 rides is 1375. About there. 8 rides is $10. And 13 rides is $375. Puts me there. If I draw my line, I'm going to get something that looks like that. Obviously, you're going to use a ruler, and you're going to get an actual straight line. But this is what I got. What is the slope and y-intercept? Well, I'm not even going to use the calculator. The slope is y2 minus y1 over x2 minus x1. So what I can do is I can pick 2 points on that line and calculate the slope in between them. So if I pick 8, 10, and any other point, I'm going to pick this one. That first point was where was that first point at? The first point was at 3 and 1625. So I've got 16.25 minus 10 over 3 minus 8. And of course my calculator doesn't want to work right now. So it's going to be 6.25 over negative 5. It's going to give me a slope of, when I divide that, got 6.25 divided by 5. I'm going to get a slope of negative 1.25, and my y-intercept is, if I drew my line straight, it looks like it'd be about 19 or 20. I'm going to say it's 20. So once again, in the context of the problem, what do the slope and y-intercept mean? The slope is the rate of change, which is how much money we are losing every time we ride the bus. So the slope how much one ride on bus costs, and the y-intercept, remember that's where it crosses the y-axis, which is in this case the amount of money that we have. It's going to be the initial amount on the ticket. Alright, moving along. I guess we're back to number 1. You find a line of fit for a set of data and calculate the correlation coefficient for the model to be negative 0.75. Which statement best describes the fit of the model of the data? So positive versus negative for correlation coefficient just means whether it has a increasing or decreasing slope. So negative just means there's a negative correlation. And then good versus bad is how close that correlation is to 1 or negative 1. So if you're close to 0, whether it's positive or negative, if it's close to 0, it's a bad fit. If it's close to 1, typically we say about like 0.85 or higher, 0.9 or higher makes it strong. So negative 0.75, that is a weak negative correlation, which makes it not a good fit. So that's going to be C. Alright, number 2. There's a known relationship between the forearm length and the body height. The table shows arm lengths and heights from a randomly selected sample of people. Use graphic calculator to find the correlation coefficient. So we're going to do new document, list and spreadsheet, name it arm, name the other one height, go down to cell 1, 25, 26, 27, 32, 31. And then my height, 160, 175, 178, 190, and 183. And we're going to go back, we're going to do the same statistics, stat calculations, linear regression. X list is arm, Y list is height. Hit OK. And this time, the thing we're looking for is R. That is the correlation coefficient. So that is 0.89. And we can say that that is strong because that's really close to positive 1. Next side. Which statement below might be caused by the statement the more the air conditioner runs? So remember, cause is like cause and effect. So one is directly related to the other. So the more the air conditioner runs, the less time individuals spend inside. Nope. That's not it. It's not a direct cause and effect. The longer you will have to let your car warm up. Maybe, maybe not. The warmer it is outside. Probably. But does that necessarily, I mean, you could run your air conditioner in the winter. That doesn't make it warmer outside. The only thing that has a direct cause and effect is the more the air conditioner runs, the colder the house becomes. Number 2 shows the prices of burger and soda at 8 different restaurants. Is there a positive or negative correlation between the two? So the easiest thing we could do with this is actually go to our table. Actually, I'm going to just create a new table. And we could look at the data, or we could actually compute the data. So 4.5, these are all my burgers. 4.5, 4.75, 5, 650, 450, 750, 5, 525, and then my soda. times 250, 3, 325, 4, 275, 350, 3, and 350. And I'm going to do it real quick. Stat calculation, linear regression. We got burger, soda, and when we look, my R value is 0.75, and it's a positive number, so that is a positive correlation. And we know there's a positive correlation. It says explain correlation coefficient is greater than 0. It's a positive number, so it's a positive correlation. Is there a cause and effect between the cost of burger and soda? Or is there a lurking variable? So lurking variable was something else that might be going on that we don't account for in the data. Because R is 0.75, it's kind of strong, but it's not really strong correlation. So that leads me to believe that there's probably something else going on. And we talked about this in class that burger and soda prices. A soda should pretty much cost the same everywhere. So soda might cost different values based on location, like whether you're buying it like a McDonald's or a Quick Trip or like a fancier restaurant. So those would be things like lurking variables. So not cause and effect. There is probably a lurking variable.